Algebra 2 students, first of all, I apologize for not being able to be in class today. I had an AD meeting yesterday, and today I have a meeting in our own school building. So today's lesson, we've been working on solving systems, and we've done this by graphing, which is fairly easy at times. Sometimes it's harder if those points or that point of intersection is not exact. We did this by substitution, which I think you've been very successful at. Easy to use if it's very easy to get a variable by itself, or if you already have one by itself. And today's method, which personally is my favorite, is elimination. So the idea of elimination is taking a system of equations and trying to eliminate a variable by doing multiplication with addition. For example, in the system that I have right here, I'm looking at the 2f and the f. And I'm thinking that if I multiply this second equation by a -2, 2f and a -2f would eliminate. So if I distribute that -2, I get a -2f plus 2g is a -4. And now when I add these two equations together, 2f minus 2f eliminates. 3g plus 2g is 5g. And 9 take away 4 is 5. I divide by 5, and I get g to be 1. All right, then just like in the substitution method, I can plug this back in. To either equation, again, I'm going to pick the one that will be easiest for me, which I think is this one. And I would have f minus 1 is equal to 2. Add the 1. So f would be 3. And f comes before g, so I could list that point as 3, 1. And then you could check it, and it would check in both equations. So I multiplied the bottom by -2, and I eliminated the f. All right, if you look closely at this one, you could have also multiplied this bottom equation by 3. And then you would eliminate the g. You'd get the same answer, okay, but it's just another way of doing the problem. In this example, we've got 2x plus y is equal to 6. 3x minus 2y is equal to 16. I'm looking right here, and I'm thinking that if I can multiply this top equation by 2, I would be able to eliminate the y's. I have -2y, so I wanted to get positive 2y. So if I do that, I end up with 4x plus 2y is equal to 12. And now I can add these equations. I get 7x, the y's eliminate, which is what we're looking for, and it equals 28. I divide by 7, and I get x to be 4. So to get that y, I'm going to substitute this back in. 2 times 4 is 8, so I have 8 plus y is 6. I could subtract the 8, and I get y to be -2. So therefore, my solution is 4, -2. All right, now in some cases, you might have to multiply both equations by something. And in this example here, if I wanted to eliminate x, I would have had to multiply this top equation by 3, and then the bottom one by -2, because that would make 6x and a -6x. Okay, but that would be a little bit more work. We want to look for the most efficient, easiest way of doing the problem. Now in this example, there isn't really an easy way of doing this by just one multiplication. So in this case, if I want to eliminate r, I can multiply the top by 2, realizing that's going to give me 6r. And then I'd have to multiply the second one by a -3. which is going to give me the negative 6r. So now multiplying this all the way through, I have 6r minus 4t is 2. I have a negative 6r plus 9t is a negative 27. The r's are going to eliminate. I end up with 5t is equal to a negative 25. And t would be negative 5. Substitution. So put this back in. I'm going to put it into, I think either one of these equations is about the same deal. So I put it in the top one, I'd have 3r minus 2 times minus 5 is a plus 10 equals 1. Subtract 10. 3r is a negative 9, and r would be a negative 3. R comes before t, so negative 3, negative 5 would be your solution. Okay? Just to show you another example here on this one, since there's multiple ways of doing this, if I would multiply the top, if I want to eliminate the t here, if I multiply the top by 3, that's going to give me a negative 6t. I would need to multiply this bottom by a negative 2. And then I would have 9r minus 6t is equal to 3. And then I'd have a negative 4r plus 6t is equal to a negative 18. And you can see if you add these up again, you're going to get 5r. The t's eliminate, you get negative 15. That's going to give you your r to be negative 3. You're going to get the same solution. All right, so if you turn to the 3.2 practice, we did 1 through 9 yesterday, page 15. We did 1 through 9 yesterday by substitution. Your next assignment is going to be 10 through 18, doing these by elimination. Getting you started here on number 10. We've got a system of equations. And if you look at this very closely, just by adding directly, these would already eliminate. You would have nothing that you would need to multiply by. This is kind of a unique case. So we just directly add them. We get r to be 5. If I plug that back in to the top, I have 10 plus s is 5. And so s would be negative 5. Okay, looking at number 11. I've got 2m minus n is a negative 1. 3m plus 2n is 30. Now, in this particular case, if you just add them directly like we just did, nothing will eliminate. So we've got to do some type of multiplication, and I believe the most efficient, easiest way of doing this would be just to multiply the top by 2, because that is going to eliminate n. I'd have 4m minus 2n is equal to negative 2. The n's eliminate. I'd have 7m is 28. n would be 4. And then you're going to plug this back in and solve for n. All right, so hope this helps you with your work today. Again, I wish I could be in class, but continue to work through this. Make sure you're doing these all in your notebooks. Make sure you're being an organized method so each problem looks very similar to it and neat and organized. And work on 10 through 18. If you get those done, great time to complete other assignments like 1 through 9 on 3.2 and 3.1, 1 through 10. Have an outstanding day. As always, if you need any help, please come get help before school, after school, whenever you need. I am very willing to help you. Have a good day.